Okay, good morning once again. Today we're going to continue our discussion on panel data regression. And last time we distinguished between um, an ordinary least squares method, a multiple linear regression, as compared to a panel data regression. If we're dealing with a data where you have several cross-sectional units or several individuals, several units, several individuals uh, taken at one point in time, okay, over, of course, several attributes or variables, then when we're trying to establish, when we want to establish the relationship between a particular variable with the other variables, then we use the ordinary least squares method. Okay. However, when you have information of the different units taken across several points in time, then that's a panel data, and we would like to we're going to use another method. No? It's not the ordinary least squares method or the pooling method. So by way of review, we said that uh, panel data is very popular in finance and econometrics because most of the data are of this nature. Okay? Yung data natin, for example, our unit or our individuals, our countries, and then we take data about the countries, whatever data we need to take or we are taking, whether it's macroeconomic data, financial data, taken across several points in time. In fact, most of the research sa sa finance, sa department natin, sa course nyo, are make use of panel data. So it's very imperative, it's very important that we look at how to conduct an analysis of panel data. And we said that we can have a balanced panel data or unbalanced panel data. By balanced panel data, if you start with, let's say, 10 ASEAN countries from 2010 until 2020, the same 10 ASEAN countries, then that's what we call a balanced panel data. If at several points in time, nababago yung makeup ng data, then that's what we call an unbalanced panel data. Okay, so last time we were working on this data set, okay, and we looked at, I think I introduced to you for the first time, this code chunk, okay, where we can already identify the packages, and then if the packages is existing already in your machine, in your computer, in your R, then you just require it. Otherwise, you have to install it first and then require it. Okay? Ba't may PLM dito? So, right, so I'll run this, okay, just to require the packages. Okay, so the packages are already uploaded. All right, then we were looking at the rental data set. I will not run this again because I have already run this. So this is our rental data set. Okay, so you have 14, 23 columns, 23 variables. We're not going to use all of them. Okay, some of them have missing values. Okay, so you have here city, and you can see here CT1, CT2, and your year is 8090. So this one tells us that data was taken at year 80, 1980, and year 1990. Okay, so you have here the variables that we're looking at is the population, the enrollment of the students, rent. Okay, and we started looking at this, and we're interested to know what affects the enrollment, okay, in a particular town, in a particular city. Okay, so let's go back to our code here. Okay, we know that this is a panel data. Okay, by now you should be able to identify whether a data is panel data or just a simple cross-sectional data, or as distinguished also from a time series. On the other hand, a time series only takes a look at one unit, okay, taken across several points in time. So I hope those three types of data sets are very clear to you: cross-sectional data set, a time series data set, and a panel data set. So let me pause for a while and kindly chat, please, class, if those different data sets are clear to you. So if you're given a particular data set, would you be able to identify if this is a cross-sectional data, a time series data, and a panel data? Kindly chat, please. Yes or no? Okay, good. Thank you. That's good. That's good. All right. So I'm happy that you will be able to distinguish between these three. Okay. Now let's review what we did last time. So here, it's important that okay, if we check, okay, let me just do it here, structure of a rental. Okay, maybe this should be already a panel because, okay, but if we have not yet converted the structure into a panel data, then this should appear to be, okay, yeah, I haven't run that, no? It's a data frame, okay? It's a data frame and 128 observations, 23 variables. And you notice that the city is integer, the year is integer, and there's this Y90, which is also an integer. Okay, this is supposed to be a dummy variable, okay, with the year 1990 as the benchmark, year one. Okay, so in panel data, it's important for us to convert the data into a panel data frame. Okay, so here we're creating this object rental underscore P or rental panel. And then we're converting the rental data set and we're defining the index. Okay, the index. So for a panel data, you have to identify what's the unit, what's the individual, and of course, what's the time frame. So in our data, the variable city is your unit and the variable year is your time frame. So that's how we convert our uh, ordinary data frame into a panel data frame. So let me run this. And then if I once again run the structure, so where's the structure here? Structure of rental. Let me change this to rental P. Okay. So I'm just running it here in our console. I'm taking a look at the structure of rental P. Okay, this object. So you can see here now that rental P is a okay. So it has been converted into, it still maintains its data frame, but it's also added another feature to it. It's now treated as a panel data. Okay, and then take a look at the index. The index that we defined, city has now become a factor, and year also has become a factor with 2 levels. City also is a factor with 64 levels because there are 64 different cities here. Okay, so this is what happened when we used the p data dot frame, and the p data dot frame. Okay, just to for us to know where it's coming from. Okay, so this is from p data dot frame. Okay, this is coming from the PLM package. So the PLM package has the, oh, sorry. Oh, no, this is rental. Why is it Woolridge? Uh, Here. All right, there. Class here. Pdata.frame. There you go. Okay. So an object of class is a data frame with an index attribute that describes its individual and time dimensions. Okay, so that distinguishes it from the ordinary data frame. Okay, all right. So, and it's easier to work if the data has already been converted into a panel data. It makes it easier to work with it when we do panel data analysis. Okay, so what we did here was to create an object called KIPS. This is what we're going to include in our data set. So we're using log rent, the dummy variable y60, and then we have the log population, and then the log of average income and the percentage of students. We looked at this last time. Okay, so let me run that. And then we're creating this object rental view. Okay, so this rental view is rental P, and then brackets KIPS. So which means we're going to include uh, KIPS. No? Okay, because okay, let's see again. Let's summary of rental P. Okay, what's included in rental P? Okay, it includes all the variables. Okay, better to view it. So let's view rental P view rental underscore P. So let me view rental P here. There. So it includes all the variables. Okay, so city up to year 1990. So still 23 variables, just like our rental. Okay, no difference. The only difference is that rental P is considered as a panel data. So this is an index, while rental does not have one. Okay, so and then we created this object rental view, which is rental P, and then we are only subsetting KIPS. So what's KIPS? KIPS includes 1, 2, 3, 4, 5. The five variables. Plus, of course, since rental P is indexed, it will also include the city and the year. Okay, so let's run this. Let me run this too. Okay. So take note, here you have the index. You have the city and the year. City year, city year. So this is what happened when we converted it into panel data. Okay, so we have here the log rent, the year, the log population, the log average income, and the percentage students. Okay, if we get the structure of rental view, we can see here that rental view is a panel data, okay, with 128 observations and 5 variables. Okay, so you have the city factor and the year also as a factor. And then we have log population. And then you have, okay, what are the others? So it keeps on repeating the factor, city, and the year. What's important is this is also a panel data, okay? Because we're just subsetting we're just subsetting the rental P, which is a panel data. Okay? Okay, so let me pause for a while. Clear so far, class? So far, yung discussion natin up to up to converting it into a panel data. So we have this object rental view. Okay, clear so far, class? Okay, good. All right. So now our data is 64 cities, okay, with 2 years, year 80 and year 90. Okay, so here I defined the variable, which of course you can get from the rental package. So I will not do that anymore, but if you recall, class, we can get that information, the rental, and look at the different variables and the definitions of each. Okay, so here last time we also did the summary. Okay, so let's now model this. All right. Of course, the first thing that we can do is disregard the index component. Disregard that this is a panel data. Okay, so that's the usual practice. Let's do this using ordinary least squares. Okay, so for OLS, we're not looking at the panel data component, panel component. Okay, so we can just use the LM method. Okay, and we can just use the rental method, the rental data set, which is a data frame. Okay, since we're just using the ordinary least squares and treating this as a cross-sectional data. Okay, so take note, we're treating this as a cross-sectional data, and we're not going to utilize the panel data component. So, okay, so we're regressing log of rent into Y90. Let me check if class of rental $Y90. Okay. So integer. Okay. So this should be considered as a factor. But let's run this first. Okay. Because Y90 is supposed to be a dummy variable. It's not supposed to be an integer. Let me just put a space here. Okay. All right. So let me run this. Okay, so the result is that you have all the variables except for log average income log population are all significant. Okay, log population is significant at the 10% level of significance. Okay, 0.07. One dot here. Okay, this is one dot there. Okay, so this is interpreted regularly. Okay, of course, how do you interpret, for example, log average income, this 0.57? So your dependent variable is log, log, and then your average income is also log. So this is interpreted as a 1% increase in average income will yield a 57% increase, or 0.57, or 57 cents. Okay, because this is 0.57 increase in rental. Okay, so that's how you interpret when both are logged. Okay, also this, assuming this is log population is also significant, then how do we interpret this? Log and log. So a 1% increase in population will result to a 4% increase. Okay, 4% increase in rental. Okay. Okay, so here our comment is that since this is just an ordinary least squares, so we're not looking at this as we did not treat the variables, the data as a panel data, then we can see here the result. The P, the adjusted R squared is, let's, adjusted R squared is around 86% here, 85.68%. And overall goodness of fit, p-value is practically 0. Okay, so we say that overall the model is able to explain, okay, the uh, the dependent variable log rental overall, okay, with the p-value of practically 0, f-stat of 190.9 on degree of freedom 1 and degree of freedom 2, 4, and 123 respectively. And the model is able to explain the variability of our dependent variable rent 86%. Okay. So any questions regarding this output class? Once again, may I request you to chat if so far clear yung OLS natin. I'm sure this is quite clear to you already. Okay. But what should be improved here? Yeah. Thank you. All right. What is one thing here that should have been done? Class, would you like to comment on if you were to do this, what should have been done? With one of the variables, with one of the independent variables. Okay, here, class, no? This one. Anyone? So let's see, class, what would have happened? Yes, thank you. Sophia, kindly share your answer to everyone. Yeah, why 90 here? What if it was not treated as an integer, right? Yeah, what if it was treated as a factor? Because why 90? It's a classifier, right? So let's copy this. Okay, let's copy this whole code chunk. Control C. All right, I'm going to Control V. All right, so let's make y90 as a factor. Okay, you can convert a particular variable, okay, into a factor by putting this one. So let's make it OLS1, summary OLS1. Okay, so here I'm changing the factor y90 and I'm telling R to consider it's a factor. So let's run this. Okay, so what do you notice here? You notice that the answer is the same, di ba? Parehong-pareho yung model natin. Okay. And although, you notice, although we converted y90 as a factor, okay, 0.26227, the answer was still the same, 0.26227. Why? Bakit kaya pareho lang din yung yung answer? Even if here y90 was considered as a integer, and here we treated y90 as a factor. Why do we have the same result? And then here you have 1. Why is that, class? Do you have an answer? No dummy variable. Okay, when we use the factor, it will automatically dummify it. No? It will automatically dummify y90. Okay, the reason that the answer is the same is because our data, our rental, our y1990 is just binary, 0 and 1 lang yun. Okay, so if your data is 0 and 1, if it's binary, then you'll have the same answer. Okay, but however, if this was not binary, then we would have different results. Okay, it just so happened that this is binary. It's just 0 and 1. So it's as if it was already dummified. Okay, the mere fact that this is already 0 and 1, even if it's being treated as an integer, okay, will have the same result if we converted this into a factor. Okay, so I hope, guys, it's clear. You might be wondering, why is y90 treated as an integer? Why did we not convert it into a factor? Okay, the result will be the same. And the reason is your y90 is already binary. It's, well, when you say binary, it's already dummified. Okay, it's 0 or 1. So whatever result you get there, for example, since y90 is 1 and y80 is 0, so y90, when you interpret this, it will be in relation to y80. So this means that the 0.26227 here means that the rental for 1990 is higher by 26% as compared to year 1980. Okay, so that this is what this means. Okay, this is interpreted in relation to y to 1980. Okay, all right. So I hope that that's clear, class. Okay, let me request once again for you to chat if so far that explanation is clear. Okay, how about the rest, class? Okay, good. Thank you. Okay, now what we did just now was to make use of the OLS method. Okay, and using the OLM function. Now this can also be done using the panel linear model. Okay, from the PLM package, we can use this. However, we have to define. Okay, let me just. Okay, so you have the same function, log rent, regress on y90, etc. Data is still the rental data. Okay, and then model is equal to pooling. Okay, and then since we're using the rental data, which is a data frame, we have to identify the index. Okay, had we used rental underscore p or rental underscore view, this would not be necessary. Okay, so if you're using PLM, we have to identify the index. Okay, either you use a data that's already treated as a panel, or you can use data that's not a panel but you identify the index. However, this actually becomes irrelevant, this index here, even if we're using rental, because the model that we're asking R to use is pooling. Pooling means that you disregard the index, you disregard the city and the year component. Okay. All right. So you can use the PLM function. Okay. For OLS by defining it to be pooling. Okay. So if we run this, we created this object called pooled. You'll have the same result. Okay, same result as in the pooled as in the OLS. All right. Then last time also what we did was to use our Stargazer package in order to give us a good printout of the results. Okay, now for this one, okay, we tried to run this last time yung co-plot. Now this will build unfortunately this does not work well with our data because ang daming ano natin, ang daming cities natin 64. This would work well if there are fewer cities, and then you can see the behavior of log rent. Okay, if we have only let's say uh, 10 cities maybe, or even less than 10, this would work well because you can see the movement of long rent over the years, year one and year two. Okay, so it will compare 1980 and 1990 across different cities. Okay, so that you'll have a very good comparison. Maybe we'll have another example where we can see how this works. Okay, and we're going to use a data that does not have so many cross-sectional units. Okay, so here we checked for the residuals, right? Okay, let's go back. We'll go back to this one. Okay, because I want already to. Did we start using the fixed effects model in class last time? Kindly chat, please. I forgot because if we already did the fixed effects model. Yes or no, please?
Not yet, sir.
Not yet. Okay. All right. So I think I mentioned last time that there are three important methods in dealing with panel data. Number one is your pooled method, which is your ordinary least squares. So if it's pooled, okay, we disregard the panel data component. And then we have fixed effects. And lastly, random effects. Okay. We will not be able to discuss everything, okay? But we will reinforce, since panel data is a very important topic here in in our subject, we will have at least one more week to discuss all of this in greater detail, because I want you to be very comfortable dealing with panel data, especially so that most probably in your thesis you'll be making use of your panel data. Okay, now in fixed effects we're going to make use of okay. All right. Why don't we do this? No. Okay. Before we go to fixed effects, let's open a new R Markdown file. Okay. I'd like to take this opportunity to do a little bit more of a practice. Okay. Okay, let's open a new R Markdown file. Just to reinforce what we have learned so far. Because for fixed, I'm thinking that I think we will need about an hour or so to do that. So let's just practice first. Okay, then let me see. Let's make use of another data. Let's call it data. Okay, and then in the Woolbridge package, I'd like us to use the CPS there. Current population surveys, CPS. So this is from Professor Farber, okay, from MIT. CPS, a comparison between 78 and 75. Okay, so here, CPS. So this is from the Woolbridge. Okay. All right. Before we go to the fixed effects, let's have some more practice about the functionalities of PLM. Okay, and let's just view this. Okay, so we're creating this object data, and it's the CPS 7885 data set from Wooldridge. And let's view this. Okay, error in, why am I getting an error? Error in comma. Why comma? Comma? Pwede naman dapat yung ano. Doesn't want the single quote. Mm-hmm. Did it run, class? Nag-run sa inyo, class? Huh? Bakit? Error in, what's wrong with this? Ano nakalagay sa inyo, class? Ganun din, error in comma?
Yes, sir.
Bakit? Data. Yeah, pero tama naman yung function natin. Yeah, just like this one. Ba, ito yung rental natin. Ay! Binago yung syntax. No? Okay. So, kailangan in codes, no? Okay. Bakit ayaw? Package is equal to Wooldridge. Tama naman spelling. Help me guys decipher the error. Kasi ito, di ba nag-run to eh?
Sir, wala po ating alt minus.
Ha? Ay, wait. O ano? Ay, nako. Yeah, oo. Ba't nga ba yun, no? Oh, walang function, no? Walang function dito. So we're creating this object, no? Sige, ganito na lang. Wag na natin lagyan ng pangalan. Ito na lang pala. Sorry guys. So this should be view. Dapat view. Ito na lang pangalan ng object. Pero pangit kasi dot na lang. Sige, okay na yun. So the function should be data. No? Sorry about that. So, hindi kailangan to. No? Pwede naman walang quotes yung ano eh. Okay, let's try this. Yeah, sorry about that. My bad. No? Okay. So practice lang muna natin guys yung mga PLM functions and then we go to magta-time na rin ano. So I need so next meeting I need pag magsimula tayo fixed effects tayo kasi I'll be needing 1 hour for that kasi maraming maraming permutations yung yung fixed effects, no? We'll discuss yung difference in difference, yung first difference, yung medyo family of fixed effects model. So I'll be needing more time for that. So with this, let's work on this first. So there are 15 variables here, 1,084 entries, no? Okay, so ano yung mga variables na to? Let's take a look. Names, ano yung names natin? May CPS 78. Okay, so ito yung mga variables natin, no? Education, okay, age, etc. So this is similar to the data we were working on, log wage, no? Only that ito, anong difference niya? Dito may year tayo, no? Year 1978 and 1985. So dalawang years. Dalawang years. And then so these are people being interviewed, no? Kinuha yung mga data nila. Tapos both in 78 and 85. Okay? All right. Were you able to follow, class? Sorry about the code a while ago. Walang function yung inano ko kanina. So data tapos I created the name called data and then walang kaya nag-error siya kasi R will not know what to do. Okay. So were you able to get the data, class? Okay. How about the others, please?
Yes, sir.
Okay, good. Thank you. So let's spend the rest of the time, guys. Let's do first an OLS. Let's do an OLS. Control Alt I, and then let's regress our log. Okay, so I'll just make one function. Summarize natin yung LM natin ng log wage, and then we're going to regress it, shift tilde. So let's use the Y. Okay. So experience muna, no? And then plus, and then remember, guys, how do we square the experience? Let's use the experience squared. If you recall, how do we square the experience without introducing that in our variable? Kasi may experience tayo dito, no? Actually, may experience squared dito. Pero let's assume wala ito, no? As a practice, how do we square? How do we do a transformation of a variable inside the LM function? Anyone? Alala nyo? Class? Do you recall? Naalala nyo si I, class? Diba? Pag nagtra-transform tayo, okay, we have to put it in inside the I, no? All right? Experience squared. And then we can get the, if we want to use the percentage, no? So divide by 100. Okay, so we're experimenting here, no? So we're regressing log wage on experience and then square natin si experience yung percentage niya. Percentage change, which is, so we divided by 100. And then sama natin si union. Okay. Ito si union. Binary na siya, no? Okay, so although, let's see, class, so CPS, and then tingnan natin yung class ni union. Okay, ano yung class niya? So it's an integer, but then again, class, we said, since this is binary, okay lang to, no? Kahit hindi siya natin gawing factor, the result will be the same. Okay, kasi 01, 01, 01 lang yan. Okay. Then, ano pang variable ang gagamitin natin? Okay, now, I don't know if, hindi ko pa yata na-discuss sa inyo to, no? Yung year 85 times educ, okay, plus female. Okay, then comma, yung data natin is equal to CPS. Okay. Let me see. Tama na ba to? Okay, take a look at this class, no? So experience and then experience squared divided by 100 plus union, oh, sorry to. Then you have here y85 times education plus female. Okay, so what will this do? In here you're interacting yung education at saka yung year 85. Pati yung female at saka yung year 85. Okay, so let's see first what will happen here, and then let's discuss the results. And this is I don't think I already have discussed with you yung using the times, did I? And using the yung colon function sa LM. We were supposed to discuss that, pero I don't think na-discuss ko na sa inyo. Have I, class, yung times factor using in LM? Could you kindly chat, please, kung na-discuss ko na sa inyo? Not yet. Sige, sige. So that's good. This is a good opportunity for us to learn more about how to deal with doing functions inside the LM. Okay, sige, good. All right, so let's run this. Ano nangyari? May kulang ba ako? Error in extracting variables. Could you help me, class? Let's check kung ano yung mali ko dito. Ay, mali ito. Sorry. Okay. Yung transformation natin dapat sa loob. Okay. Sorry, class, no? Ito yung transformation natin, experience squared over 100. So I failed to put the parentheses here. No? Okay. So let's see. Open, close, open, close. Okay, so I think this is correct already. So make sure, guys, yung I natin may close, ha? Okay. All right. So I think I discussed I with you before. If you're transforming the dependent variable, okay lang na hindi naka-I. Pero pag independent variable yung tina-transform, dapat it should be inside the interaction parameter. Okay, so let's run this. There. Okay. Take note of the no? Take note of the results. No? So notice this one, itong y85 times education plus female, it will include education, it will include female, it will include y times education, it will include y times female. Okay? And also it will include y85. So the use of this, yung times na to, it will include yung mga variables niya, yung y85, yung education, yung female, at saka yung interactions nila. Take a look at this. So you have here yung experience, and then yung squared over 100, yung percentage niya. Okay, then the union, then y85, which is not significant here. Education is significant. Female is significant. So on the average, female employees receive 0.316 less than their male counterparts. And then this one also, Okay, we're going to discuss this next meeting. Ano ibig sabihin ng Y85 education? Y85 female. Okay, were you able to get the answer right, class? Paki-chat naman, please. Okay, how about the others? Okay. All right. Konting time na lang, no? So let's tingnan muna natin. Let's just work quickly on the on the itong data na to. But let's see the structure of CPS 70N. Let's take a look at the structure. Okay, so it's a data frame, no? It's a data frame. And if we're going to use this data as panel data, then we have to convert that into a panel data. No? So again, we're going to use the PLM package. No? So for example, CPS 78, ano ba maganda? Gawin natin may underscore na to. .p na lang, no? .p, which means this is panel data. Okay, so how do we convert it into panel data, guys? P data dot frame, no? Okay. And then, diba, if you recall, class, okay, so this is very important, no? This one. The data and then yung index natin. Let me just copy this, Control C. So this is CPS 78 underscore 85. Okay, ano yung index natin? What's our index? Hmm. Wala pa lang ano to, class, sorry ah. Okay, very sorry for the choice of the data. Wala siyang individual component. Hindi naka-identify yung okay. Okay, so I think I chose the wrong data, no? Okay, so we can choose we can convert this into a panel data kasi wala tayong component na individual dito eh. Walang ID kunyari. Naghahanap ako ng ID na person 1 and then person 2, no? Wala siya. Okay, did you get me, guys? It's already time, but just one more minute. Class, did you get me why we can convert this into a panel data? Kasi there's no identifier for the individual. These are individuals, no? Kaso wala tayong index dito na nagsasabi kung Y85. Okay, unless, actually pwede natin gawin yung ano, no? Kaso regressor kasi sa, ay, Allah, o nga pa. I thank you for reminding me. Nako, grabe. Sorry, sorry. Yeah, o nga, no. Akala ko ano lagi, sorry guys ha, nalilito ako. I was thinking na ano na time na, no? 8:30 on. Hanggang 9 o'clock pala tayo. Good, good, good. Okay, so more time tayo. Ay, nako. Last time din, ganun naman na over ako. So, remind ako ng students na ano na kasi hanggang ano lang dapat kami hanggang ano ba 'yan? 12:30. Tapos I was thinking 12:45. So 12:34 na, tapos sabi ko, 1 minute na lang tayo. Hindi naman sila nagsabi sa akin na sobra-sobra na. Anyway, good. Thank you so much for reminding me. Grabe na ano ako sa time ha. Okay, so anong pwede natin magamit dito na ano na we can use Y85 kaso ginagamit siya na ano time component to eh. Okay. Year 85 at saka 78. Okay, 78 oh. Okay, sige, ganito gawin natin class, no? Gawin natin yung ano, yung Y85. We can use this as our parang ito yung ano natin individual. Ay, hindi pa pwede. Sorry, sorry. Kasi dapat 1,084 entries. So 2 years. So these are 500 plus 500 plus 542 ano individuals to no? There are 542 individuals kasi 1,084 entries. So divide by 2 yan, 5,042 individuals. So we got their information in 1978 and then I'm not even sure if these are the same individuals. Pero palagay ko same individuals so taken again in 1985. Okay, wala tayong variable dito unless na ilo-load natin muna to sa Excel tapos lalagyan natin ng ano ng ibang variables, no? Okay, so let's use another data. I'm sorry class, no? We have to do some manipulation here first and put an index, kunyari 1 up to 542. Okay, and then tapos another 1 up to 542 sa year 85. That way, completely defined yung ano natin, yung panel data natin. Okay, let me pause for a while. Class, are you able to follow what I'm saying? Okay. Kasi, sabi natin, we would like to convert this into a panel data. Yung year, meron tayo. Yan. Ito yung time component natin. Yung problema natin, yung individual. Wala ditong variable na nakalagay, for example, sana may ID dito, no? 1, 2, 3, 4, 5, 6 hanggang 542. And then pagdating ng year 85, another 1, 2, 3, 4, 5, 6, no? 542. That way, meron tayong 542 different units taken at 2 time frames. So that's a panel data yon, no? Ito wala, kulang ng ganung variable. Unlike this one sa rental natin, tingnan niyo ha. So sa rental, tingnan to class. 'Di ba? Ito city, no? Ito yung identifier natin eh. City. In particular yung rental muna kasi naka-panel na to. No? Ito yung index nyo. Diba? You can see here class, pag na-convert na natin into panel data, may index na siya. 1-80, 1-90 as compared to this rental. Okay, wait. Itong rental na to, yung rental data set natin, ayan, tingnan nyo, walang index, di ba? Index niya 1 lang, 1, 2, 1, 2, 3, 4, regular lang. Okay, itong rental fee, ang index niya 1-80, 1-90, 2-80, 2-90. Okay? So ito, hindi natin pwede ma-convert kasi wala tayong wala tayong identifier ng individual dito. Okay, never mind. So let's use another data. Okay. Marami namang data set si package, si Wooldridge. Control Alt I. Okay, so let me may list ako kasi ng mga data set dito sa ni Wooldridge. Hanap ko ng give me a few seconds. Okay, ito. Let's use si crime, no? Data crime 2. Okay. Package Wooldridge ulit. And then let's view this.
Sir,
Yes.
nawala po yung share screen niyo.
Ano wala yung share screen? Sorry. Thank you. Share screen. Wala. Ba't nawala ka lang? Okay. Is it now showing, class? Class, is it now showing?
Yes, sir.
Okay, thank you. Now, I think that was a very good also lesson for us kanina, no? Itong CPS 7885. Okay, you cannot directly convert this into a P data kasi wala tayong index dito ng individuals, ano? Okay, you can do this kung maglagay tayo ng index, and that can easily be done. Pwede muna nating you can load this first to Excel, and then mag-insert tayo ng data na na parang ID niya. So 1 up to 542. Why am I saying 542? Kasi there are 1,084 entries. At 2 years to, 78 at saka 85. It means for 1978, 542 entries, no? 542 entries for the different individuals. And then nung 1985 kinuha ulit, I think, wait tingnan natin. Most probably, class, same individuals to, no? Same individuals na in-interview na 1978. And then after 8 years, in-interview ulit sila 1985 to see kung ano yung changes dun sa log wage, no? Sa wages nila. Okay? All right. Siguro let that be siguro i-try nyo, class, babalikan natin to next meeting. Pero ang gawin nyo, i-download nyo to sa Excel, no? And there's a command for that. I-research na lang, madali lang 'yon. So you can download this in Excel or as a CSV file, and then you put another variable, ID siguro, tapos 1 hanggang 542, and then 1 hanggang 542 ulit. No? Okay, is that clear, class? Paki-chat naman please kung I make sense, no? Kung maliwanag yung instructions ko. I hope you'll do it, class, no? I hope you take time to do that. Download it into Excel or CSV, and then insert yung IDs na 1 up to 542, and then another 1 up to 542 for year 78, and then for year 85. Okay, clear yan, class? And then upload it again, and then i-convert na into a panel data. Class, clear? Okay, thank you. Good. Good. Dalawa lang nag-clear. Okay, good. Thank you. All right, sige. Balikan natin yung data natin. I'm using now crime. Tinignan ko yung list ng data sa Wooldridge, no? So crime 2, run natin to. Hmm, okay, wait, So we have here, ano yung year natin? Na-identify ba yung years dito? Ito, may year tayo, no? Year. 82 and 87. 82, 87. 82, 87. 82 and 87. Okay, so dalawang years to, tapos 92 entries, no? That means 46. Guys, sorry, sorry. I think pwede pa rin natin gawin din 'tong isa, no? Yung si CPS, no? Okay. Yeah, now I recall. No? Medyo na-recall ko na ngayon na pwede, no? Pwede nating i-convert into a panel data. Okay? Despite the fact na wala siyang ID. No? Kasi parang lumalabas ito na wala ding ID, ba? So kunyari ito, dapat may ID. Parang dito kanina, no? Yung sa rental fee. May city tayo dito, di ba? Ito yung unang year, 1980. Tapos pangalawang year, 1990. Okay, so same city yan, 1 and 1. Okay, ito, 2 and 2, 3 and 3. So city 1, city 2, taken at year 80 at saka year 90. So ito, si crime 2, meron din tayong year dito, 82 and 87, 82 and 87. Pero wala tayong ID dito, no? Wala tayong ID dito na city, city 1, city 2. So these are data about the crime rates in a particular city in 1982 and 1987. So definitely this refers to city 1, 82 and 87. And then this refers to city 2, 82 and 87, no? So since there are 92 entries, which means there are 92, there are 4, how many cities, class? Paki-chat nga please. Kung naiintindihan ko ano yung sinasabi ko o baka hindi naiintindihan, baka malabo yung pag-explain ko. Andi dito yung year index natin, no? 82 and 87. Ang tanong, ilang cities to or kung cities man to or ilang states maybe, no? We have to check kung anong city ba to o state. Sige nga, tingnan natin, crime 2. Let's check the metadata. Yan, crime 2. Okay, collected by David Dicho. Okay, final project. County siya, county and city, years 1982. Unfortunately, I do not have the list of the cities, but there are. So how many cities are there, class? 1982 and 1985. So kinuha yung population ng 1982 and 1985, kinuha yung number of crimes, no? Total number of index crimes, etc. So here is the metadata. No? Ito yung information about that very rich crime data sets at the county or even city level. Okay. All right. So this is city, no? City or county. Okay. Back to my question, class. Ilang cities to? How many cities are we looking here? Are we taking into consideration here? 3 cities ba? Bakit 3 cities, Charles? Okay. Yung west, north, east, and south, these are the, asan ba yan? Tingnan natin sinasabi ni Charles. West, north, east. Saan yung west, north, east, and south? Okay. Okay. Itong tingnan natin itong 1982 na to, class, ito yung information about this particular city. Tingnan nyo si west, north, east, and south. These are dummy variables kasi 100 siya, And this is where the location of the crime is. So, malamang to, meron pang isa to, east. Okay? Nakadamify siya, 100. It means that, okay, 1000, 100. Okay, balikan nga natin to. If city is in west, okay. Location siya ng location siya ng, so apparently yung US, no? Tapos, yung mga cities either nasa west siya, or nasa northeast siya, or nasa south siya, yung location ng city. If you take a look at the map of the US, yung city ba yan nasa northeast? Nasa south ba yung city na yan? Or nasa west ba yung city na yan? Okay, but my question is, how many cities are we looking at here? Okay, the answer, class, is, di ba 46 cities? Okay, ito city 1. City 1 to. Kinuha information niya in 1982, tapos kinuha ulit in 1987. Diba? Ito city number 2. Kinuha information ng 82. It's the same as this one, class. Pareho nitong rental. Ito, diba? City 1 nung 1980, 1990. Diba? So there are 128 entries here, which means there are 62 cities ang tinitingnan natin. 62 cities noong 1980, tapos same cities noong 1990. Okay, in the same manner, itong crime 2, okay, you have 46 cities here. 46 cities. Tapos, one city in 1982, and then tinignan ulit yung record niya noong 1987. So how many cities are we looking at here? 46 cities. Okay, clear yun, class? Clear? Pa-chat naman please kung clear. That we're looking at 46 cities here. And then dito may information tayo, saan located yung city na yan? Nasa west ba yan ng US? Nasa northeast ba yan? Nasa south ba yan? Okay? Class, clear ba? Okay, good. Thank you. Thank you. So, ito, pwede ba nating ma-convert into panel data to? Kasi si crime, okay, si crime is, let's take a look at the structure of crime. Si crime 2, ang structure niya, it's a data frame, no? Yan, data frame siya, no? Data frame si crime 2. And we'd like to convert that into a panel data. Okay, pero wala rin siyang wala siyang index, no? Unlike yung real rental natin, di ba? Si rental natin, yan, di ba may city, may naka-identify, may ID, no? Okay, ito wala. Parang CPS 7885 din. May year tayo, pero walang ID. But you can still do that. Now I recall, sorry. Since nasabi ko ngayon, no? We can convert this Okay, so how do we now convert this into a panel data? Para magamit natin siya for panel data uh, analysis. How do we do that? No? So we can now, let's create now crime2. Let's make it .p, panel, alt minus. And then we can use the p data .frame. Okay? And then sabi natin, di ba, identify the data. Okay? And then pwede natin gawin class na we can define the index to be equal to. So ang index natin will be ilang ilang data, ilang cities. So 46 siya. Okay. So one way to convert this into a data, into a panel data is to identify ilan yung units dito. Ilan yung cross-sectional units. So it's 46. So sige, tingnan natin. Okay. Na-recall ko na to, no? 46. So let's try again to see ano yung structure ni crime2.p. So ano yung structure niya? All right. Okay, now you can see that si crime2, ano na siya? Panel data frame na siya, no? See here? And if we i-view natin si crime2.p, view natin siya. All right. Take a look at this, no? So ito, city 1 at year 1. Ang disadvantage lang ng ganito class is that unlike yung sa rental kanina, di ba? Yung rental, since naka-specify yung city at saka yung state, kinumbine niya yung city at saka year pa lang. No? City at saka year, naka-combine yung ganito. No? Right? So mas magandang indexing dito as compared to this one. Si crime to kasi, di ba, walang nakalagay yung ID ng city. Yung year lang meron. So, anong lesson sa atin ito? And anyway, it's so easy to identify the city, di ba? Or the ID. So, mas maganda sana kung nakalagay na dito yung may index tayo ng city. Okay? Kasi may year na. All right? So, pag convert natin yun into a panel data, and in-index natin kunyari si city at saka si year, ang index ngayon magiging 1-82, 1-87, 2-82, 2-87. Mas maganda, no? Kasi dito ang nangyari lang, kaya naka-index dito na 46 cities, year 1 and year 2. Okay, and it will be a good experiment to see what will happen what if this was arranged as 82 lahat, tapos 87 lahat. Kasi kung kunyari ang arrangement nito, year 82 muna lahat, no? 46 na 82. Tapos year 87 lahat. Okay? Tapos and then we index it equal to 46. Anong mangyayari? Magiging 1-1 ba? Tapos 1-2? Tapos 2-1, tapos 2-2? Kasi kung ganito gagawin, okay, mamamali na to, di ba? You get me, class? I do hope I'm making sense, no? Medyo ano lang tayo ng time, kasi I would have wanted to do this, no? Pwede natin i-arrange tong year, no? Gawin natin 82 muna lahat, tapos 87. And then had we indexed it, magiging ano ba siya? Magiging 1-1, 1-2, 2-1, 2-2? Kasi pag ganun pa rin yung indexing, mali na yon. Kasi it should be 1-1, okay, 2-1, 2-2, 1-1, 2-1, 3-1, 4-1, 5-1. Kasi yung first number dito will refer to the city, okay, and the second number will refer to the year. Okay, I hope guys I'm klaro yung explanation ko, no? Sana if there are any questions, please feel free to ask these questions. And I don't expect naman na na immediately makukuha natin to. Let's just check the dimension. Pwede natin gamitin si panel dimension, si crime 2, no? .p. Okay. Tingnan natin yung panel dimension. Okay. It's a balanced panel. N is equal to 46. Time natin is equal to 2. And N is equal to 92 yung total number of observations. So ang lesson sa atin dito, class, when we're dealing with panel data, it's better to, of course, include a variable for your cross-sectional unit, no? Okay, kung city man yan or country man yan, etc. Okay, it would be best to do that para yung indexing niya mas klaro, no? Okay, just like here, no? Yung sa rental fee natin, mas maliwanag yung kasi na-identify natin dito yung index kung ano yung cross-sectional unit natin at saka kung ano yung year. Dito hindi natin na-identify. So ganun din dito, class. So let me just insert here. Dito pwede rin pala natin yung way na hindi straightforward. Sulat ko na nga lang. Panel natin. So, P-data. CPS 78. Okay. Index natin. So, dito, ilan yung sa CPS? 542. No? Ito, tingnan natin ito 78, no? 78, tapos 85. Ito na una lahat ng years. Okay, let's see what happens here. Hindi ko pa nagawa to 542. Time na pala, no? So, class, last minute, tapusin lang natin. Let's see what happens here. Alright, then i-view natin. CPS. Yung P. Samahan ko na ng P9. Sige. Okay. Ito yung sinasabi ko, class. No? Take a look at this. So, mali na to. Mali na yung indexing dito. Why? Kasi yung year na to, 78 mo na lahat tapos 85. But take a look at how it is indexed. Okay, take a look at this. 542, this means CT 542-1, then 542-2. Pero mali ito, guys. Hindi CT 542 to. Okay, do you see the point here? Ito, this is CT1-1, this is CT2-1, CT3-1 dapat to, CT4-1, CT5-1. This is CT1, CT2 hanggang CT542. Yung -1 dito yung year, no? Okay? So here the indexing will be wrong. Kasi ang binabasa dito ni R, si CT1 ito, and then si CT1 to year 78, and then CT1 to year 85. And this is CT2 year 78, and then CT2 year 85. So that's wrong. That's wrong. Okay, guys, do you get my point? Pa-chat naman please, and then we end that. No? Pa-chat please if you got what I mean, class. Okay, thank you. All right, so yung indexing na ganito, class, it will only work if your data is arranged this way. No? Pero if your data was arranged 1982 mo na lahat, tapos 1987, if it was arranged by CT, it will work. Okay? But had you indexed it into 2, ayan, no? Take a look at that. So ito tama na. No? 1-1, 1-2. Hindi, mali pa rin, no? It will not work, no? Class, sorry. No? It will not work. Alright, kasi ito 2 cities lang eh. No? Wait. So ito ang lumalabas, yung year natin, 542 years. So which is wrong. Okay, so again guys, ang pinaka-moral lesson dito, when you deal with final data, make sure that the unit and the year and the time is incorporated. Okay? All right, so that ends our discussion for today. I'm sorry if I extended. I'll stop recording.